Hi everybody, Freshies, this is Mr. Martineau here, and Miss Mandrelli on the video camera, and today we're going to bring you a lab about light. So we're talking about electromagnetic spectrum this week, that different wavelengths of visible light, and we know the visible light doesn't take up very much of the entire electromagnetic spectrum, but visible light is broken down into the colors of the rainbow, right? So everybody's seen a rainbow, but really what a rainbow is the separation of white light, which is not really white, it's clear, but they call it white. Why? Because there's no other word for it. But what Newton found out way back in the day is if you take white light and you separate it through a prism, not unlike this guy here, and you've seen this effect probably in windows and aquariums and any piece of glass that's cornered in your house, if light hits it the right way, you get a rainbow out the other side, and that's basically how rainbows work, right? So what we're going to look at today is if we take light and that white light and we pass it through a filter, not unlike this filter right here, right? So this is a green filter. So when I turn the light on inside of this filter, green light will come out. So only green is allowed through. Then we have a red light right here. So there's a white light in here, but we're passing it through a clear red filter. So only the red parts of the wave come out, right? And then we have blue. So again, same deal, white bulb on the inside, blue lens on the outside, acts as a filter, lets everything, absorbs everything but blue, only allows blue through. So what we're doing here is we're taking white light and we're forcing it to be of a particular wavelength. Different wavelengths of light and different frequencies of light will give you the different color of light. And remember, all the colors of the rainbow added together get you white light, white light. Okay, but what we want to do today is what happens when we isolate particular wavelengths of color and then combine them together. So what happens when we combine red and green or red and blue, right? Also, and I mentioned a moment ago, these three colors that I have, these filters of red, green, and blue, these are called the primary colors. So really, the colors of the rainbow can be broken down into the primary colors. The three primary colors are red, green, and blue, and all other shades, all other hues, all other types of color are simply mixing of these three types of light by a process we call additive.
Yeah.
An additive process.
It's the additive color process.
Additive color process. Couldn't think of it. Right? So from that you get your different colors. So what we're going to do today is we're going to see if we can predict what we get when we add different combinations of these three primary colors together. So what we have here is our little board. You noticed it a moment ago. So we're going to have our lights here. Okay, we'll turn them on and off. We have a lens here. The only purpose of the lens is to focus the light, just to make it easier to see. And then we have a backdrop right here, and we're going to project. So the light's going to come out of these bulbs through this lens and project onto the back of the screen. And the hope is that we'll be able to see what we get when we do that. So lights are going off. She's going to turn that on.
All right, so I'm plugging this in.
Yep.
All right, and wait.
Yep.
Walking over here to shut the lights.
And boom.
Ooh. No, okay, hold on.
Okay.
I know the screen is black, but
Okay.
Okay.
So what we're going to do is we're going to take that out of the mix all together in that. So right now we just have the red shining through the lens. And what we're going to do is we're going to add the green color to it. So there's the green right there. And so let's make a prediction. Red and green.
Well, we know what we get when we mix red and green pigment together.
Right. That's different.
That's mixing atoms.
Right. So that's a different situation. So if you're in art class, you're going to see Miss Bruzy after, and they say, they said that when you add red and green, you get this color, but that's for ink. Paint and pigment add differently than light does. It's a different thing altogether. So we're going to look at this right now. So let's see what we get. So we're going to. So we're looking at the space in between. Right there.
Actually, let me keep the phone like this. All right, so point to it with the pencil.
So we're looking at that spot right there.
Because that's where the red and the green are
Yep, so there's
overlapping
your red
and
circle.
mixing.
There's your green circle, and they're mixing in the middle. So what would you call that?
It's hard to see on here, but it really is a pale yellow.
Yep. Let's see if I can
Yeah.
try.
There it is. There it is. There it is. It's really not white. It is a pale yellow.
Yeah.
Okay.
Okay, super. So we did that. So let's do red and blue.
Okay.
So we're going to add those two together. So what do you think you're going to get? Let's find out. So we're going to do... There we go. So that's a little more... Oh, maybe it's not. I don't know. Looking at that right there.
Yeah. Again, hard to see on the camera, but it's really like a pale purple.
It's purple.
It's a light purple.
It's purple.
Yeah.
All right. So what was the last one? Wait, that one.
We're gonna do blue and green,
right.
and then we have to do all three.
All right. So we got blue and green coming at you. Let's see.
That's good. Ooh.
It's not great. There we go. So we're right there.
And it's really like a pale blue.
Yep. Would you
Like
call that
like
teal?
a robin. Yeah, you could go teal. You could say like a pale teal.
Yeah.
Or a pale blue.
Yep. So that's
it's a greenish blue.
That's a teal or greenish blue.
Okay.
All right. Well, we don't want to say green blue because it's blue and green.
Yeah.
So
I'd say teal or like
teal.
Yeah.
All right. And let's go all three.
This is the fun one.
The pièce de résistance.
Let's see. So put them nice and close to each other. Let's see. Ooh, it's right in the, are they staying near each other? There it is right in the middle, right in the very middle. Hard to see.
Yeah.
But look at that. So we've got our additive colors of light, red, blue, green.
Mm-hmm.
And look at, we've got yellow, we have orange, we have purple.
Right.
We have this beautiful blue. And right in the very, very center, I'm going to grab the pencil, right here.
Yeah.
This is the mix of all three additive primary colors of light. What does it look like to you?
Well, it looks whitish. Mm-hmm. Yeah.
It is white because white light is.
Yeah. That's all the
It's
colors.
all the colors of the visible
You do see the whole
together.
rainbow going left to right. You see red and then orange and then yellow. And then that weird aquamarine and then blue and then green and then...
Yep.
Yeah. All right.
All the colors are
That's
there.
cool. All right.
All right.
All right. So hopefully you wrote all that down in your data table. That was the additive color process for light. Again, pigments are different. So if you...
Ooh, this is creepy.
If you did that with ink and paint, it would be...
Go ahead. There we go.
Okay. Then it would be black, or brown. I don't even know. So it'd be different.
Yeah.
But this is not the same thing. So when you... future, let's say you see this on a test or a quiz and you see what happens when you add red, green, and blue light together, don't say brown because that's ink.
That's paint.
That's different. That's different. This is white. So anyway, so that was Lab 22A. I hope you liked it. We did the best we could with what we had. Again, this is Mr. Martineau, Miss Mangerelli on the camera, and I bid thee adieu.